guys, so welcome back to the GChem, and today we are going to be start the second part of the solution chapter. In the previous parts, that is a part 1 of the solution, we have discussed number 1, that is definition of solution. Second, we have discussed the classification, and third, we have discussed the concentration terms. Many of the students comment on the different points, and thanks for that all and for your response on this video. Now today we are going to be study about the solubility, the next part of your syllabus, that is solubility. In the solubility you have two things. I can just go in a simplest way to explain you, that is solubility of solid in liquid and solubility of gas in liquid. The solubility of solid in liquid is defined as the amount of solid solute in grams dissolved in 100 gram of solvent at given temperature to make saturated solution. On the other hand, solubility of gas and liquid is defined as amount of gaseous solute in ml dissolved in 1 ml of solvent at given temperature and pressure, because here the term pressure is also come in the picture, to make saturated solution. Now the second thing we discussed is a factor affecting the solubility. So in this case, if you can discuss about the factors, the first comes nature. And we know that in both cases, nature means like dissolves like. Means polar solute will be more soluble in polar solvent and non-polar solute will be more soluble in non-polar solvent. Second is temperature. Generally, the solubility of solid in liquid increases with increase in temperature, but there are certain exceptions in which the solubility either decreases or in some cases we got the irregular behavior, first increases and then decreases. Now the second term is basically in the case of the solubility of gas and liquid, it always decreases with increase in temperature. Now the next term we can see that third is effect of pressure. Effect of pressure. Basically, the solubility of solid in liquid is ineffective from pressure because solids are highly incompressible, but the solubility of gas in liquid increases with increase in pressure. Means when you increase the pressure, the solubility of gas in liquid increases. And this concept is used by Henry and termed as Henry's law. So the next point comes Henry's law. What is Henry's law? Henry's law is used to explain the solubility of, or it is applicable on the solubility of gas and liquid. And according to Henry law, the solubility of gas in liquid is proportional to the pressure applied on it. Means solubility of gases, that is a mole fraction of solute, is proportional to the pressure. X is equal to K into P, or if you can inverse it, it becomes partial pressure of gas is equal to KHX. Here P is the partial pressure of any gas. X is the mole fraction of gas. And KH is known as Henry's constant. It is applicable on the nature of gaseous solute and liquid solvent. Basically, Henry's law is applicable, the applications of the Henry's law. Number one, in respiration. Second is in scuba diving or deep sea diving. Third is at high altitudes. And fourth is in soft drink preparation. Now, the main point of this chapter, from where actually the chapter starts, is Raoult's law. It is just advancement of Henry's law, which is applicable on each type of solute in each type of solution. Basically, we can say Raoult's law is the expanded form of Henry's law. It is applicable on each type of solute in each type of solvent. Basically, Henry's law and Dalton's law combinedly form the Raoult's law, or we can say Raoult's law is a combination of Dalton's law and Henry's law. How we can say it? We can mix A and B. So according to Dalton law, P total is equal to sum of partial pressure of A and partial pressure of B. And according to Henry law, P is proportional to mole fraction of A and PB is proportional to mole fraction of B. So PA becomes XA PA naught and PB becomes XB PB naught. So P total becomes XA PA naught plus XB PP naught. On this topic, you can get the direct questions from your book. If any doubt, you can comment me and I can explain you. This is called Raoult's law. After studying the Raoult's law, the next point comes, that is ideal and non-ideal solution. So what are the ideal and non-ideal solution? It's very simple. The solutions which obey Raoult's law, and non-ideal is do not obey, which do not obey Raoult's law. Means for the first one, P total is equal to PA plus PB. But for second one, P total is not equal to PA plus PB. So it is called deviation from Raoult's law, and this is of two types. Deviation from Raoult's law is two types, that is positive deviation from Raoult's law and negative deviation from Raoult's law. In the positive deviation, P total becomes more than PA plus PB. Here P total is less than PA plus PB. Here delta V mixing is positive, here it is negative. Delta H mixing is positive, is negative, or we simply say the interaction in solvent and interaction in solution. So here you see, in the case of positive deviation, means vapors are more, so interaction becomes weaker, and here this interaction becomes stronger. Example, I can explain you with the example, like in the alcohol, there is present is H bonding, means these alcohol molecules are attached together with H bonding. But when we mix any of the organic solvent like alcohol with chloroform or CCl4, the interaction will be London disperse forces, and we know that LDP is weaker than H bonding. So interactions get weaker, it show positive deviation. On the other hand, in the case of negative deviation, you can take a acetone. In acetone, sorry, just a minute. In the acetone molecule, there is dipole-dipole interaction because there is a Dale positive and Dale negative. But when we can mix chloroform in acetone, so it becomes H bonding, and we all know that H bond will be stronger than dipole-dipole. So simply say it shows a negative deviation. So now we can make a graph for these all. Number one, for ideal solution, means a solution which obey Raoult's law. For ideal solution, let this is 100% A and this is B. So this indicates the curve for PA, and this point is PA naught. Here this is PB naught and PB. I am just thinking that B will be less volatile than A. B will be less volatile than A. and this line which combining the both one is P total. This is for the ideal solution. But when you can move to the non-ideal solution with positive deviation, it is very easy that you can make, again this is the vapor pressure and composition. Here also it is vapor pressure and composition. The expected lines are this one for ideal one, which I am just making a dotted lines. But in actual, due to positive deviation, what we obtain the lines above these straight lines. And for negative deviation, if you draw these curves between vapor pressure and composition, the expected lines are this one. Negative deviation means the lines come below below the expected ones. And one more point to be understand here, that vapor pressure is inversely proportional to boiling point. What is the boiling point? How you can define the boiling point? Boiling point is a temperature at which vapor pressure of liquid becomes equal to atmospheric pressure. Say for example, this is atmospheric pressure, and we have two liquids A and B. A has this amount of vapor pressure and B has this amount of vapor pressure. So if we want to vaporize A, we have to heat to this amount, and for B we have to heat more. So this diagram easily explains that vapor pressure of A is more than vapor pressure of B, but boiling point of A will be less than boiling point of B. Why? Because for A we have to heat lesser in content. So from here, if you can draw the curve for boiling point and composition, for ideal it will be this one. For ideal, if you see, the boiling point of A will be less because its vapor pressure we have taken in above side. So the component which have a lower vapor pressure have a higher boiling point and vice versa. For positive deviation, if you draw the curve of boiling point with temperature composition, the expected would be this one. But in the real picture, for positive deviation, we can get the negative curve here because boiling point with minima. Boiling point with minima. The same we can do for the negative deviation. Negative deviation, so if you draw the boiling point curve with composition, the expected line will be on the upper side. So this curve will be exactly opposite than the vapor pressure curve. Why they are opposite? Because the boiling point is inversely proportional to the vapor pressure. Understand this all? From here, the one definition always asked in the 1 mark questions of the CBSE board, and many times they can ask you azeotrope. isotopic mixture. This is known as constant boiling mixture. It is a special solution which has same composition in vapor state as well as liquid state. Otherwise, the composition of liquid state and vapor state are different. Normally, if we can take the equilibrium of any solution made by A and B, the mole fraction of A in liquid state will be XA equals to PA upon PA naught and XB equals to PB upon PB naught. And for vapor state, the composition of A is YA equals to PA upon P total and YB equals to PB upon P total. Understand मेरा बच्चों? You can get the question on this also. So this is the second part. Till here what we have studied: number one, definition of solution. Number two, classification. Number three, concentration terms. This we have studied in part 1, and in today's part, that is in the part 2, we have studied solubility of solid in liquid and gas in liquid, then Henry's law and its application, and last one is that is Raoult's law, which is a very important and which is the base for the next colligative properties, which we can discuss in part 3 of this solution. So for any doubts or any questions, you can just comment me and I am happy to give you the answer. And thanks again for your responses, and soon we can meet within a colligative property in the part 3 of this chapter. Bye.